Hey guys, for this video we're going to be looking at another projectile motion example. This time it's going to be asymmetrical. Just wanted you to see this so you don't get a surprise when it comes up. Alright, let's have a look at the question. Okay, so standing on a cliff 150 meters above the ocean, you throw a ball with an initial speed of 8.4 meters per second at an angle of 20 degrees above the horizontal. How long does it take to hit the water, and how far does it travel in this time? Right, I've taken the time to draw this, which is really beneficial in understanding what's going on. Right, so you can see that this is quite asymmetrical. You start at 150 and you end at 0 when we look at the y-axis. So this is a bit different to the example we saw before. And just quickly, with projectile motion, what's really important is that you can separate the x and the y motions and treat them differently. They don't affect each other. They're happening simultaneously, but one doesn't affect the other. So that's just a little side note on projectile motion. Right, the other information we got given from this was that we have an 8.4 meters per second vector, velocity vector, and it's 20 degrees above the horizontal, and we know, once again, we've seen this many times now, that a vector is composed of an x and y component. Now, I've quickly just drawn up Vx and Vy because we've done that so many times, and I got that Vx equals 7.9 meters per second and Vy equals 2.9 meters per second. Now, what we need, there's a few ways of going about this. We can sub this into the equation, the kinematic equation that says y equals y0 plus vy0t plus half a t squared. However, I'm going to do this a bit differently because that's how we did the last question. So I'm going to show you a new way of working this out. What I'm going to find is the velocity in the y direction at the end of the motion. Alright? So it'll make sense why I did that in just a second. So we have this equation on our formula sheet. Obviously it doesn't have y's in there, but I'm putting them in to make it relevant for this question. So final velocity squared equals initial velocity squared plus 2 times the acceleration times the change in y. Right, so our initial velocity squared was 2.9. That's what I worked out before. Plus 2 times the acceleration, well, we know that's minus 9.8. All there is gravity. And the change in displacement in y, we started at the top of a 150 meter cliff and we ended at the bottom. So we actually went down by 150 meters. So that minus is really important. That'll trip a lot of people up in the exams. So really pay attention when it comes to pluses and minuses. Okay, so type that all into our calculator, take the square root, and we end up with Vy equals 54.3 meters per second. But we know from school maths that when we take the square root, this can be positive or negative. And while it may seem a bit arbitrary, it's actually really important because it can affect our answers in the coming parts of the question. So we need to actually, to decide which one it is, we need to have a look at our initial diagram. Now, if you look at the velocity vector at the end of the motion, it's down like this, isn't it? Right? And if we look at the y component, that's going straight down. So that velocity is actually negative. If we're defining up as positive, this velocity is negative. So the answer that we want to take over here is minus 54.3 meters per second. So that is really important concept and can get you or lose you a mark or two in exams. So that's really important. Right, now why did I find the final velocity of the body in the y direction? Well, it's simply because we have another equation on our formula sheet that looks like this. Right, that looks like this. Now, we know what our initial velocity is, we now know what our final velocity is, and we know what the acceleration is. So we can actually find the time of flight using that. So how long does it take to hit the water? Well, let's just sub in our values. Right, and chuck that all into your calculator, and you'll find that the time of flight, how long does it take to hit the water? 5.83 seconds. Right, so had I not remembered this minus, I might have got a negative time, which is impossible, and it doesn't really make any sense. So that minus just became really important. Right, so that's another way. You can find the final velocity, magnitude of the final velocity in the y direction, and then use this equation to find the time of flight. Now, to find how far I travelled horizontally is quite simple. Done that before. Once we've got the time of flight, we just sub it into this equation, which we've seen many times now. Just remember that all these equations are on your formula sheet. A formula sheet is absolute gold when it comes to exams. Right, x0 we know is 0, v0 in the x direction I worked out before was 7.9, and t we now know 5.83. Right, the acceleration is 0, so it's just going to make that all 0. Type that into your calculator. The ball travelled 46 meters. Right, so we've answered the question. Important things to remember is that we separated the x and y motions, and we treated them like they weren't affecting each other. And this new way of working out projectile motion questions using this equation and the other one with the vy squared. And that concludes this lesson. Thank you, guys.